This is problem 21 from the photon. In problem 21, we have a bar chart for the energy of each incident photon, the kinetic energy of each emitted electron, and the work function of the metal surface shown for a specific run of a photoelectric effect experiment. Remember that the equation for the photoelectric effect experiment is the energy of the photon, which is the initial energy that you have, is equal to the energy needed to release the electron, which is the work function, plus the kinetic energy of the electron afterwards. Or you can rewrite this as kinetic energy of the electron is equal to H times F for the electron of the energy of the photon minus the work function. But we have to have the energy of the work function plus the kinetic energy of the electron equal to the energy of the photon. So if we have 2 blocks for the electron energy and 2 blocks for the work function, then the photon energy is 4 blocks. Now, for each change in the experiment listed below, we're going to construct a bar chart that illustrates the changes in each of the variables. So for number 1, we're using a brighter light source. Well, a brighter light source would have more intensity, but you would still have the same energy for each photon since the energy of the photon is proportional to the frequency. So the frequency is staying the same, you have more intensity, so you can release more electrons. But for each photon, and this is for each incident photon, the emitted electron would still have the same energy. So for one photon, if you had 4 blocks before, we're still at 1, 2, 3, 4, since the frequency hasn't changed. The work function doesn't change. So that means the electron still has the 2 blocks, which you add to the work function to get the 4 blocks for the photon energy. In part 2, you use a higher frequency light source. Well, now if you increase the frequency, now your photon has more energy. So if your photon has more energy, before it had 4 blocks, so now let's make it 1, 2, 3, 4, 5 blocks. So our photon has 5 blocks of energy. Our work function is still going to be the same. If it's the same metal, the same work function. So we got our work function here, but the energy that I have from the kinetic energy of the electron plus the work function has to equal the energy of the photon. So if this is 5 blocks, now my electron's going to have more kinetic energy because the photon had more energy. Then, in part 3, we're using a metal with a lower threshold frequency. Well, if the threshold frequency is lower, that means that the work function is lower. I guess we kind of skipped this before, so let's go back to my equation for the kinetic energy of the electron. The photon has to have enough energy to release the electron. The lowest kinetic energy that you could have is 0. If the energy of the photon is less than the work function, the photon doesn't have enough energy to release the electron. So the threshold frequency would be when the kinetic energy is 0. That's when the energy of the photon is equal to the work function. So if the energy of the photon is equal to the work function and the energy of the photon is also equal to Planck's constant times the frequency, this would give us the threshold frequency. So that's the lowest energy that the photon can have, where the electron is still going to be released, but with a kinetic energy of 0. So if we use a metal with a lower threshold frequency, that means the work function is smaller. The work function was 2 blocks before, so let's make it 1 block now. And we're using a metal with a lower threshold frequency, but that doesn't change the energy that the photon has. The energy of the photon was 4 blocks in the initial experiment, so we'll keep that at 4 blocks. And then I would have to add 3 blocks here. So this is 1, 2, 3, 4. I'd have to add 3 blocks to the 1 block that I have for the work function in order to get the 4 blocks for the energy of the photon. In part 4, we're using a metal with a work function greater than the photon energy. The photon energy initially was 4 blocks. The work function is greater than the photon energy. We'll make that 5 blocks. But how much kinetic energy would you have in this case? Well, your photon energy is less than your work function, so the kinetic energy of the electron is 0. But notice that our equation isn't going to work in this case. Our equation is not going to work in this case because the photon energy is less than the work function. So even if you made the kinetic energy of the electron 0, the photon energy is less than this. So you'd have to have a negative kinetic energy for the equation to be true, but you can't. And so if your photon energy is less than your work function, then this equation no longer holds.